Engineering is more than just circuits and code. It's about solving real-world problems. Welcome to the CMTEQ Engineering Podcast, where we uncover the challenges and innovations shaping the future of electronics, embedded systems, artificial intelligence, and of course, power system engineering. I'm Chad, your host, and together we'll explore the insights that make great engineers even better. This podcast is your space to learn, explore, and engage with cutting-edge technology in a simple and interactive way. Whether you're a hobbyist, a student, or a professional, there's something here for everyone. For this inaugural episode, we're diving into a fascinating topic: breaking down the basics of embedded systems. Embedded systems are the silent heroes of modern technology, powering everything from smart watches to industrial automation systems. Today we'll uncover what they are, explore the components, see how they are applied in real-world scenarios, and even discuss how you can get started. So stick around till the end, where we'll also answer some beginner-friendly questions about embedded system. Let's get started. So, what are embedded systems? Let's begin with the basics. What exactly is an embedded system? An embedded system is essentially a compact computer designed for a specific task or set of tasks. Unlike your laptop or smartphone, which can perform a wide variety of functions, an embedded system is purpose-built. For example, think of your microwave oven. It doesn't need to browse the internet or play games. It simply controls heating, timing, and user input through buttons. That's it. That's its job. And it does it efficiently. Embedded systems are characterized by three main features, right? Number one, real-time operation. Many embedded systems, like those in cars or medical devices, need to respond instantly to inputs. A delay could lead to critical failures. Number two, resource constraint. They often operate with limited processing power and memory while still delivering reliable performance. Number three, reliability. Since they are often used in critical applications such as heart monitors or industrial automation, failure is not an option. Right? For example, in the world of substation automations, you cannot afford the machines that control the automations of a substation to suddenly fail. There will be a major blackout. Now, if you take a look around you, you'll find embedded systems everywhere. Your washing machine, your smart TV, even your smart watch. They all rely on these powerful task-specific systems to function. Components of an embedded system. So, what makes up an embedded system? Now that we know what embedded systems are, let's break them down into their main components. At the heart of any embedded system is the microcontroller, which is a tiny yet powerful chip that acts as the brain of the operation. It processes inputs, runs instructions, and controls outputs. Popular examples include your Arduino for beginners and STM32 for more advanced projects. Next, we have memory. There are two primary types: RAM, which is a temporary memory used while the system is running; ROM, or flash memory, which stores the system's firmware, the software that runs the hardware. Embedded systems also rely heavily on inputs and output devices. Right now, your inputs include sensors like temperatures, pressure, or motion sensors that gather informations or data, if you like. Outputs include displays, motors, or actuators that interact with the environment. So finally, there is the power supply. Many embedded systems are designed to be highly energy efficient, especially in battery-operated devices like fitness trackers or solar-powered IoT sensors. Now let's talk about the real-world applications of embedded systems. So where do embedded systems shine in the real world? In power systems, they play a critical role in monitoring and controlling energy distribution. For example, embedded systems in smart meters measure power usage in real time and provide feedback to utility companies. In IoT devices, embedded systems are the backbone of smart homes and industrial automation. Imagine a smart thermostat that learns your preferences and adjusts the temperature automatically. That's powered by an embedded system. In consumer electronics, embedded systems enhance devices like smartphones, cameras, and gaming consoles. Take your phone's GPS for instance. It calculates your location accurately while using minimal power. And in automotive technology, embedded system power features like anti-lock braking systems and engine control units. They are even paving the way for self-driving cars by integrating with advanced sensors and artificial intelligence. So, how to get started with embedded systems? Now, if you are intrigued and want to explore embedded systems yourself, here's how to get started. First, choose a beginner-friendly platform like Arduino. It's affordable, open source, and comes with tons of online resources all over the internet. If you are ready for something more advanced, consider an STM32 controllers. They offer more power and flexibility for professional grade project. Start small. A great first project is blinking an LED to understand how microcontrollers work. From there, try building a temperature monitor using a sensor and displaying the data on an LCD. Or if you are into IoT, create a smart light that you can control via your phone. Resources like Arduino.cc and forums like Stack Overflows are fantastic places to learn. And of course, check out the CMTEQ YouTube channel for hands-on tutorials. So in closing and wrapping up this introductory podcast on CMTEQ Engineering Insight, before we wrap up, let's address some beginner questions I've received. So the first question, what's the best microcontroller to start with? Well, I always recommend starting with Arduino. It's beginner friendly and has a massive community for support. The next question is, how do I debug an embedded system? Well, this question is big. Start by isolating the problem. Check your connections, test your code in small parts, and use tools like serial monitors for debugging. You can also use a logic analyzer to basically analyze the signal levels coming out of your IOS. So that's it. Now, if you have more questions, feel free to reach out to me directly. Drop a comment and I will attend to your question. Thank you for joining me today on CMTEQ Engineering Podcast. I hope you enjoyed this deep dive into embedded system. Don't forget to tune in next week where we'll discuss IoT and how to connect your embedded system to the cloud. Until then, keep experimenting, stay curious, and embrace the tech world around you. See you next time.